Today we're going to continue graphing lines in the form y equals mx plus b. So this is just a reminder of the concepts that were covered last week, and then we will build on these concepts in our next lesson. So whenever we have a line in the form y equals mx plus b, we know that there's a shortcut to graphing. And before we get there, let's just recap the fact that the slope of a line can be either positive, negative, zero, or undefined. So a line that has a positive slope will go up to the right. That's because both the rise and the run are positive. So if you pick a point here and you want to get to this point here, you would go up and then you would go forward to get to the other point. And so the up corresponds to our rise, and going forward is our run. And since we are going up, this is positive, and because we're going forward, this is also positive. So our slope, which is rise over run, is a positive over a positive, which means that the overall sign of our slope is going to be positive. So as soon as you know that you have a positive slope, you know that the direction of the line has to be going up to the right. A line that has a negative slope is going to go down to the right. So from one point to the next, you would go down. So that's your rise. And because I went down, it is negative, and then I went forward, which is my run, and that is positive. And so when you input rise over run, which is a negative over a positive, your slope will be negative. So a negative slope is always going to be going down to the right. Now there are two special cases, and that is when the slope is zero and when the slope is undefined. If the slope is zero, you're going to have a horizontal line. And the reason for that is the rise is zero, but the run equals some number. We can't actually define how long the run is because this line is infinite. So when we put in the slope formula, we're going to get the rise is zero over any number, whatever we choose it to be. You go to your calculator and you input that in and you get the number zero. So if the slope is zero, you have to have a horizontal line. Now the tricky one is the vertical line. So in this case, the rise is some number. I can't actually figure out where we're going to start and where we're going to end. But the run is zero because there is no change in the x values. So when you do the slope, which is rise, which is some number over the run of zero, and you input this into your calculator, you're going to get an error message. And that is because this is undefined. It's something that cannot be calculated. Okay, and we're going to look at those in terms of graphing in just a minute. So the idea is that you always want to make sure that the slope of your line, the direction of the line matches up with the slope of your line. It's part of the check process as you're going through this. Now, if you look at the next group of questions here, our equations are in the form of y equals mx plus b. Y equals mx plus b. And in the last lesson, we discussed graphing. So m is always the slope, and the constant term b is your y-intercept. Okay, so in this case, m is equal to 1/4. So we have a positive slope, so that means your slope has to be going up to the right. In the next one, this is in fact y equals mx plus b because we have a zero here, which means our y-intercept is at zero. But we are interested in looking at the slope. The slope, again, is the numeric coefficient in front of x. So our slope this time is negative. So our line has to be going downwards. And in the last one here, y equals 4, that is the same thing as saying y equals 0 times x plus 4. So that means our slope is equal to 0. So we must have a horizontal line. So we're going to have a horizontal line. Okay, so what we want to be able to do is to predict the direction of the line. And if we are given the direction of the line, then that tells us something about the slope. So when we actually have a graph and we need to determine the slope, we need to make sure that we have, again, the corresponding sign. So if a line goes up to the right, I know the slope has to be positive. If the line goes down to the right, I know that the slope has to be negative. If I have a horizontal line, I know that the slope has to be 0. So let's take a minute and recap the graphing that we looked at last week. So I've got 4 examples here, and we're just going to recap graphing, and I'm going to do all my graphs on the same grid, and I'm going to label them. So the first thing we want to do is we want to graph the line y equals 4 over 5x minus 3. So remember, the y-intercept is -3, and our slope is 4 over 5, with the 4 being the rise and the 5 being the run. So to graph this quickly without using a table of values, we go to the y-axis, and the y-intercept is a point on the y-axis. In this case, it's at -3. Now, to find a second point on our line, we are going to use the slope to help us do this. From the y-intercept, I am going to count up 4 because our rise is 4, and I'm going to go forward 5 because that is the run. So up 4, 1, 2, 3, 4, forward 5, 1, 2, 3, 4, 5. This is now a second point on my graph, and to find a third one, I can repeat the process. From this new point, we count up 4, 1, 2, 3, 4, forward 5, 1, 2, 3, 4, 5. This is going to take me up in the positive direction, but I know that this line continues in the opposite direction. So you can actually do the opposite. So instead of going up 4, I'm going to do the complete opposite, which is to go down 4, 1, 2, 3, 4, and then I'm going to go backwards 5. And that will give me another point. And then I get out my ruler, and I'm going to connect the points, put my arrows on to show that this line continues in each direction, and I'm going to graph that line A. And now we're going to move on to the next one. The y-intercept is +2, and the slope is negative. I like to put the negative sign in the numerator so that I have a negative rise, and my run is +6. So I go to the y-intercept, and I find the number 2. Okay, the y-intercept of 2 is a point on the y-axis corresponding to that numeric value. Now this time we have a negative slope, so we know that the line has to go down to the right. So we're from the y-intercept, we are going to count down 1 because we have a negative rise, means go down, and then we're going to go forward 6. So we're at the point 6, 1. And now if I continue that, it's going to take me off my grid. So what I want to do is I always want to find a third point. So I'm going to do the complete opposite. So I'm going to go to my y-intercept, and I'm going to do the opposite. So instead of going down 1, I'm going to go up 1. But now instead of going forward 6, I'm going to go back 6. Okay. And then from this point, if you go down 1 and forward 6, you should be back at your y-intercept. And so now we have 3 points that line up. There they are. Everything should line up to give you a straight line. Otherwise, there's a mistake somewhere. Connect the points, add arrows to show that the graph continues in each direction, and I'm going to label it B, so I now know that that matches up with question B. And now we get into some interesting questions. Part C, y equals 5. This means y is always 5. That's what it means. No matter what the x value is, y is always 5 for every value of x. Every value of x. If you put it into y equals mx plus b form, it means y equals 0 times x plus 5. So my y-intercept is 5, and my slope is 0. So that means I don't go up, but I continue to go forward. So what it looks like is this. We have a horizontal line. Y is always equal to 5. Oops, I went a little bit off there. Okay, and that is line C. So no matter what, y is always equal to 5. The slope is 0, so we have a horizontal line. And our last example is x equals -7. So in this case, x is always -7 for every value of y. And as previously mentioned, this is going to be a vertical line, okay? X is always 7. Now, we haven't talked about x and y intercepts, but here, x is always 7. So it has to be the line. X is always -7, and it has to go through this x-intercept where our graph crosses the x-axis. And so here, this is the line. X is equal to -7. Okay, so it is going to be a vertical line. So we've looked at lines that have positive slopes, negative slopes, and now we've touched upon the idea of horizontal lines with a slope equal to 0 and vertical lines with an undefined slope. And those special cases are recognized because they're in the form y equals a number and x equals a number. And now you're going to practice these concepts by looking at the second handout in B.